Hey everyone, and welcome to the AI module of the course. So this week and for the next few weeks, we're going to be looking at how artificial intelligence can be applied to medicine. And in addition to looking at the ways that it can benefit medicine and improve patient care, we're also going to consider some of the risks inherent in using this technology. So first, let's start by talking about what role AI can play in medicine. So, like every other field, there's a lot of excitement around how artificial intelligence can impact the healthcare field. But there's a lot of risk here. So, the National Academy of Medicine recently released a report called Artificial Intelligence in Healthcare: The Hope, the Hype, the Promise, the Peril. And I really like these dualities that are set up in this title. So, there's hope because there's a lot of potential impact and a lot of potential good that could be done with this technology. But there's hype because the current state of it does not reflect what people maybe think about artificial intelligence. There's a lot of promise, so there's a lot of potential here and ways that there could be improvement. But there's also peril, there's danger, and there's ways that using AI can negatively impact or harm patients. So for some of the hope, here's some promising applications of AI in medicine. So Google does a lot of research in artificial intelligence, and they have an entire healthcare division. And one example is that they can use retinal scans to predict cardiovascular problems, which saves time for optometrists to have to not go through those scans or get some assistance in diagnosing them. Another application is precision medicine. So the way that drugs are typically prescribed to treat a disease is drugs only work on certain patients. And the way that it works typically is it's kind of a gamble if a drug is going to work or not. So you try one drug, if it doesn't work, you go to the next one. And that can obviously be kind of risky or at least wasteful. So precision medicine will group patients into subpopulations, and then you can decide how to treat each of those patients based on what subpopulation they're in. And so you're more likely to have a successful treatment that way. And we saw one example of AI in medicine, fictional at least, in this video that we watched in the first week of class. So if you recall, and if you want to watch, there's a link here. This video showed in a digital assistant, which was all voice controlled, could understand the doctor's text, pull up relevant information from the record about it, all just through an essential human spoken interface. So there's a lot of ways that AI had to be used here. And, like we said at the beginning, this is a far way from what AI today can do. So one way to measure the impact of AI, is something which this company Optum does, which is to do an annual survey on AI in healthcare. And the report in 2018 found that people were typically pretty optimistic about it. So most people thought that AI could improve health outcomes, decrease cost, and improve quality of care. So something to do as an exercise, and I encourage you to pause the video to think about this, is how can AI help each of these groups? So each of these stakeholders, they could all benefit or be harmed by using AI in medicine. So what specific applications could apply to each of these? So now that we've talked about some of the hope and the potential, let's talk about some of the challenges and peril. So one thing is that what we typically call AI right now is not necessarily that intelligent. So, for example, there's a lot of writing like this, but here's something from the New York Times talking about how AI hits the barrier of meaning. They don't understand things the way that humans do. And if we assume that computers have this human-like understanding, then we're prone to have that automation bias, like we talked about in the Patient Safety Week. And just like Michael Scott was willing to drive his car into a lake because the GPS said to, we are willing to do or overlook potentially disastrous things because an AI has told us to. So one concrete example of this. So here's the output of a system which detects objects and images, and it assigns a probability. So you can see, for example, that right here, the algorithm thinks there's a 99% chance that there's a human inside of this box. There's a 50% chance that there's a book here, an 81% chance that there's a chair, etc. Now, what these researchers did is they took the same image and they just added an elephant in the room. So the proverbial elephant in the room. So other than this animal being added, being photoshopped in, what else changed in this picture? Can you see any difference in the output of the system? Well, the difference is that, whereas previously it saw that there was a cup sitting on the table, now it doesn't. So why is it that if there's an elephant photoshopped into the room, all of a sudden the algorithm doesn't recognize that there's a cup on the table? If you can't think of a reason, then that's because there's not really a good reason. And this is the problem with using what are called black box models, models that you can't understand. So physicians need to make potentially life-impacting or life-saving decisions. And so if we want them to trust an AI to give them a recommendation, they need to understand why it is they want to do that and know that it's not just something like something odd with the data like this elephant that's causing them to miss something important. Another example that is potentially life-ending is if you take a stop sign. This paper showed that by putting these stickers on the stop sign, a self-driving car system mistook the stop sign for a yield sign, which is obviously very dangerous because then the car may not stop at a time when it should. So I really like this quote here. People worry that computers will get too smart and take over the world, but the real problem is that they're too stupid and they've already taken over the world. So this is something that I really like to think of as someone who works in AI, that the algorithms that we're using, while they can be useful and they can do good, is they're not as smart as people think that they are. And so we shouldn't trust them too much, and we should be a little skeptical and push them a little harder to make sure that they're doing what we want and that we can trust them. And this ties into something stated by the researcher Charles Friedman, which he calls the fundamental theorem of informatics, which states that a human brain plus a computer is greater than a human brain. And this is really what, according to Dr. Friedman, drives the push for healthcare informatics and for implementing healthcare technology. But note that on the left, it's not the computer is greater than the human brain, it's the two of them together. And so as we're developing technology to be used in medicine, this is really what we're striving to build. Not a computer that will replace a human brain or a doctor's brain, but ways that the two can work together and make each other better. Okay, so with that, I'm going to pause this video and go to the next video to start walking through the coding activity, where we're going to use machine learning to predict diabetes. And I just realized that this looks silly. Sorry that this has a typo here, but I will see you over in the next video.